Today you're going to be looking at statistical representations or graphs and the way that we represent data. The three that we're going to focus on are histograms, stem and leaf plot, and dot plot currently. So for a histogram, oftentimes these are confused with bar charts. So bar charts usually are representing some type of categorical data, which would mean it would be things like people that, if you prefer dogs or cats, things like that, not necessarily counts of people that prefer something. We organize the data into bins or a range of values, and then the height of each bin is the frequency or how often that was selected for a particular value. So if you look at the histogram on the left, their bins are age ranges of 5 years, so 0 to 5, 6 to 10, 11 to 15. And then the height of the bin represents the number of people in that age range that selected M&M as their favorite candy. So even though there's different colors, they're not selecting the color that they prefer. This is how many people preferred M&M over different types of candy. It does look like a bar graph, but in a histogram the bars should be touching, whereas in a bar graph typically they are separated from each other because, again, they're showing a different type of data in a bar graph. Histograms are considered to be continuous, so they're constructed from a frequency table, so all of the data is related, and we show that on the graph. A relative frequency histogram is constructed using the frequency in relation to the total number of data, and I have an example of that in just a second we'll look at. And then we also have cumulative frequency histogram, which is a running total, meaning that we're adding a previous group to the next group. And again, we'll look at an example of that in just a second. So this one is a frequency histogram, so we would look at that and say that there are maybe 4 or 5 people in the age range of 0 to 5 that prefer M&M as their favorite candy. 25 approximately in the 6 to 10, and that's how we would read that graph. For a relative frequency data set, or a histogram, we take our data set and you create your frequency table. So you still have the intervals or your bins over on the left side, and then your count or your frequency, sorry, this is just a frequency histogram, is listed there, and then you see that height reflected on the height of the bars. A relative frequency table it's almost like a percentage of a total. We don't take and turn them into percentages, we leave them as a decimal. So we have our data set there. We still have our count or our frequency, so there are total 17 data points in this entire data set. So to find its relative frequency, relative to the other options, or the other frequencies, we divide by the total number. So its relative frequency for data points between 0 and 10 would be 1 out of 17, or 0.06. We had no numbers between 11 and 20, so it's still at 0. Because we're thinking about all the things that could happen, your relative frequency table should add up to 1. So then if you look at the histogram, the difference on the histogram is that now rather than saying that 0 to 10 only occurred one time, we're seeing it as the percentage or the decimal, so 0.06 as it occurred in our data set. Cumulative, so cumulative is adding over time, so everything together. So we would start with our smallest interval, so we had one data point from 0 to 10, so it had a frequency of 1, so our cumulative at that point is 1. We have no data points from 11 to 20, so it occurred 0 times, so 0 to 10 still has 0 to 20 still has a cumulative frequency of 1. Then we add our next interval, so we had one data point between 21 and 30, So total in those three categories, we had 2 occurrences. And so you see the bar move just slightly from 21 to 30 from 1 up to 2. And then we make a pretty big jump in our frequency because we have 5 in the next category. So the 7 in 31 to 40 is actually showing that we had 5 in the 31 to 40 range, 21 in the 30, 0 and 1. So the bars are getting larger as we move across the graph. And so on a cumulative frequency histogram, it can be a little bit more difficult to see the individual values because we're kind of have that running total. So the next type of graph is a stem and leaf plot, or sometimes it gets shortened to just a stem and leaf, stem plot. It's created a lot like the histogram, meaning that we still have intervals of value, but we can still retain original data values. So when we graph things on the histogram, I can tell you that I had 5 values in between these 2 numbers, but I couldn't tell you what they are specifically, but I can see those on the stem plot. We have 2 parts. So the leaf represents the last digit of each number, regardless of where it falls before or after the decimal. And the stem is the other digit of the number. And typically the stem and also the leaf are listed in increasing order. You do need to have a key or pay attention to the key at the bottom that shows you kind of how to read each individual data point on the graph. And then we can also make a back-to-back stem plot, and that's where we actually can compare 2 sets of data together on the same stem plot. So if we look at the picture we have here, we have ages of parents. So the stem is your 10-digit value, right? So 30, 40, 50. And then the leaves are each individual parent. So we have 1 parent that was 31 years old, 2 parents 34, 1 that is 39, 3 that are 40, and you would continue to read the graph that way. So again, it is important to look at the key. So this example, these values actually represent in the hundreds, right? So 4 and then the break and then 80 would be 480. So that first line of the stem and leaf plot there would be 180, which is why it is important to read the key at the bottom of your graph. A back-to-back stem and leaf plot would be 2 sets of numbers, so you could compare men and women in the same category, but plot their data separately. And so you put the leaf on either side, so you have the stem in the middle, and then you have leaf to the right and a leaf to the left. And you do still want to list that in ascending order. The last one is a dot plot. So a dot plot is exactly what it says. We're going to put different points to represent data points in the data set. It does retain the original points like our stem and leaf plot, so we can look here and see minutes to eat breakfast exactly how many we have in each minute category. So each data item is a dot above the number line. You do want to pay attention to that. Sometimes if it's a really large data set, they'll tell you that 1 dot represents 5 data points, just so that you don't have really, really large graphs. But you can take any amount of data and turn it into a dot plot. You do want to make sure that it's appropriately titled and the axes are labeled so we know what the increments are. So, they're not skipping intervals on the number line or anything like that when you graph. All right, so we're going to make this dot plot here from this data. So a manager at Sobeys is interested in the distance the employees travel to work each day. She asks them how many kilometers from the store they are from home, and this is the data that she received. So again, we have small enough values that I think we can let 1 point represent 1 person's distance. We don't need to combine. So I'm going to start here. So I'm just going to count Now you could go through and list each point one time, or you can kind of do this all at one time, but I'm going to say there's a 1, 2, 3, and I'm just going to mark those off. So 1, 2, 3, and you do want to kind of keep your intervals nice and even. So then 2s, I counted 5 of those. 3s. I don't see any 3s right away, so I'm going to go ahead and 4. There's 1. Oh, I missed a 3 right there. Let's go ahead and put that little guy right down there. So I'm at 1, 2, 3, 4, 5, and there's another 3. I looked too fast. 2, 3, 4, 5. This is why I mark them out so that I can kind of see. Now there are nice things that will plot these for us, but I'm just going to go ahead and do this on my hand. So we have a 5, 2, 3, 4, 4 of those. A 6, 1, 2, 3, 4. So if I look at the data in that box, it's really hard for me to, kind of make any determination. So once I get the data into a picture, it just will make it a little bit easier for me to kind of start to approximate. And, I don't know why she cares about how far away her employees are, but maybe they're having to make some decisions about moving to a new location and need to see what that impact is going to be on her staff. So there's the 3. For 8, oh, there's a 5 that I missed, so we're going to add him over here. So 9. You just have to listen to me tap on the screen. I think it's just easier than trying to bubble those in and make those dots bigger. There's an 11. Got 2 of those. 12. 13. Alright, so let's skip over. We got 2 18s. I hope those people carpool together. There's 3. Maybe they don't live in the same area though. There's another 12. 2 15s. 14. Okay, so now that we've made that, we can describe the data for all of these graphs the same way that we talked about that on shapes of distribution last week. So I would say that this graph is going to be skewed to the right. And you can just kind of think about visually what would happen if I took and tried to just kind of sketch in a curve over top of those values. And so I can see most of the data is over here on the left side of the graph. We have a couple points over here on the right side that's pulling that to the data set. So if we're going to take and think about what is a better measure of center, that's actually going to be a median, which means that probably somewhere in the 6 to 7 range. So let's see, we've got 45 data points. So our mean's probably going to be at 22. So let's see, we can do some cumulative work here. So this would be 3, and then that would be 8, 10, 15. So I'm just counting these data points. And then this would be 24. So this would be where the median would be. So our median would be about 6 kilometers is the average distance of the employees from work. So you can do this with your histograms. All of that you can kind of take and approximate where your measure of center is for all of those values using those measures. So we're going to talk about some other types of ways to calculate statistics and other graphical representations, but these are the 3 we're going to focus on for this week.